Alrighty, welcome to chapter 3. Moving on through our course of our year here. So, ladies and gentlemen, boys and girls, we have a log graph here. So there's a couple of different ways to find your domain and range. Obviously, you have the calculator. That's definitely an option for you. But really, what you're just trying to do in this example is for the domain is remember that basically it's going to look like this one or like this one for our graph. So really, ladies and gentlemen, we can't have any negatives because, ladies and gentlemen, think of your exponent rules because remember, logs are exponents. So can you ever have an exponent give you a negative number? And the answer is no. So you're going to have no parts of this graph right there. So normally, ladies and gentlemen, boys and girls, the idea is that we have an asymptote right here at 0. Well, that asymptote is going to be related to what's inside your parentheses or what your h value is. So if I do x minus 3 is equal to 0, so I'd get x equals 3. So that's going to move your asymptote over 3 units. So that means our domain is going to be from 3 to infinity. Now, it can't equal 3 and it can't equal infinity, so we got to keep it that way. Now, the range here, sports fans, and this is another thing that's got to be tricky, and you got to be smarter than your calculator. If you plug it in the calculator, it's going to look like a square root graph. Kind of does this, okay? So you need to know that it keeps on going down forever, getting forever close to that asymptote. So that's going to be from negative infinity to infinity. So that's our domain and our range for this graph. Cool? For 18b, we're going to do the same. Change the screen there. Do the same, the idea, we're going to do x squared minus 4 is equal to 0. So x squared is equal to 4, square root of both of those. So x equals plus or minus 2. Okay, so let's take a look at that on the calculator just so we're good. So this is going to be log, hit my log button there. Oh, I got to go to math, that's right. Go to log base. So log base 2 of x squared minus 4. Notice I'm just showing you how to do this on the calculator since we did the other one by hand. There we go. In this one, you're going to see some negatives. And the reason why that is okay here, ladies and gentlemen, boys and girls, is, let me highlight this screen here so I can write on it. So, ladies and gentlemen, if I take a look at both of the functions, we notice that it's going right here and right here. Alrighty? So, ladies and gentlemen, boys and girls, the idea is it can go this way forever and this way forever, but not in between, because anything in this region right here is going to make it so your x squared is less than 0. So if I pick in 0 and plug it back in over here, I would get 0 minus 4, which can't be done, hence why the graph is not there. So our domain is going to be from negative infinity to 2, and then from, negative 2, and then from 2 to infinity. Alrighty, so ladies and gentlemen, that is our domain, and our range is going to be from negative infinity to infinity. Sorry, I need to pause, let my dog out. Righty, sorry about that. Now that I'm back here, we're going to move on to our next one here. So when we do a lot of these examples with logarithms, we do a lot of money problems. So when we're money problems, there's two formulas. Obviously, PERT, and PERT is going to be when it happens continuous. So if we look anywhere in this problem, you see the word continuous, that is going to be our formula. But in this case, we don't see that. So we're going to do the other one, which is 1 plus r over n to the nt. So p is going to be your initial amount. R is going to be, so this will be p. This will be your rate. Now we're going to change that to, because it is a percentage, to a decimal. So 0.374. And monthly is going to be your compound amount, which is your n. So in this case, my n is 12. And then 8 years is going to be my t, so my t is going to be 8. So, ladies and gentlemen, boys and girls, we'll go ahead and plug this in. So we're going to get 5,600, 1 plus 0.0374 by 12, and then 12 times 8. So I would just throw this in the calculator and let it do its thing. And so when you're all said and done, after 8 years, you're going to have $7,549.65. Cool. Easy one. All right, so it says evaluate this. So the idea of evaluating is you kind of want this inside to match this base 3, especially if you're not doing it with a calculator. So we're going to go ahead and change this 27. So if I remember, 3 to the 1 is 3, 3 squared is 9, 3 cubed is 27, and 3 to the 4th is 81. So I'm going to key in on this one, that 3 cubed. Now this is 1 over 27. So what this means if I take log base 3 of 3 to the 3, that's 27. But since it's 1 over 27, if I make it a negative 3, then ladies and gentlemen, boys and girls, that becomes 1 over 27 because negatives are going to flip it. That's an important rule for our logs. So then here we have our common base rule. So these will cancel out because of the common base rule. So our negative 3 is going to drop on down. Cool. So just to show you on the calculator, you could do also the calculator trick with a change of base rule. So the change of base would be log of 1 over 27 divided by the log of 3. And we're going to get the same answer. So if I pull out my calculator and I turn this on, hopefully, we're going to go log of 1 divided by 27, close those parentheses, divided by the log, maybe, oh, too many logs there, of 3. And notice we are going to get the same answer of negative 3. So there you go. 2 different ways to do that one. Alrighty. So once again, I want to make this inside a 3, but I'm not going to do 9 to the 5. I ain't got time for that. I mean, 9 times 9 times 9 is way too big. So what I'm going to do is I know that 9 is 3 squared, as we mentioned right here. So 9 is 3 squared times 5, because it was 9 to the 5 already. So this is going to become 3 to the 10. So these are our exponent rules here. So now we have log base 3 of 3 to the 10. And so our common base rule again, those will cancel out and we'll just get 10. Alrighty. So it says write as a single logarithm. Okay. So remember, anything that's got a plus is going to go on top, and anything that's got a minus, so both of these have a minus, are going to go on bottom. The other thing that we want to remember is any numbers in front, any coefficients, are going to be brought up to the top to become exponents. So let's go ahead and take a look at this first part here. So I'm going to bring that 2 to the top. So this is going to be ln. We should say one big ln. And then, so all this is going to be on the top here. So the 24, and then when we add it, it turns into multiplication of x squared. And then with our bottom ones here, all these are going to be in the bottom. This is going to go ahead and become a 2y to the 1/2 power. And so, ladies and gentlemen, we're going to look at this and go, you know, there is some things we can do. We can reduce this just like any old fraction. So we see right here that 2 goes into 24. So that means our answer is ln of 12x squared. And then anything to the 1/2 power is just going to be root y. Now, that's what your answer key says. I'm not a huge fan of leaving this as a root y because I still believe that you can't have radicals in your denominator. So if it was me, I would rationalize this. So root y, so I would multiply the top by root y and the bottom by root y. So this would be 12x squared root y over y, and that would be my ln. But we would accept both of these answers, and let's go with that one since that's in your answer key. I just don't like square roots in my denominator anytime. All right, so number 20, okay, we're on 21b. All righty. So we got a plus, we got a plus, we got a minus, so all that's going to go down, and all those are going to go down. Okay, so this is going to be, if we bring that 3 to the front, bring the 2 to the exponent, excuse me, I'm going to make both of those exponents. I'm going to get log base 5, big fraction here, x cubed y squared. And then bring this to the front here, and this is going to be x minus 1 to the 4th, and then this is going to be x plus 1 to the 1/2. So, ladies and gents, we'll just rewrite this as log base 5, x cubed y squared, log x minus 1 squared, and then the square root of x plus 1. Sorry, that should be to the 4th. There we go. Either one of those is correct. If you were to multiply all this out, there's no way you're going to be able to factor anything out, so don't even try. That takes a lot. All right, expanding. So ladies and gents, we're going to expand. Sorry, I did a typo, so I'm going to restart this problem over again. And I made a couple of weird word choices anyway, so we're just going to roll with it. So the first thing we're going to do is realize that expanding means that you're going to have multiple exponents. So that part needs to get transformed a little bit, and multiple exponents, multiple logs. Goodness gracious. So I'm going to rewrite this as x plus 1 to the 1/4 power, because that's the same thing as a 4th root. I'm going to rewrite this as y to the 3rd to the 1/2 power, because that's the same thing as a square root. And then I'm going to notice that these right here, we can put together to become y to the 3/2. Okay, so everything gets its own part. So I'm going to make this 4 its own part, and this 5 its own part, and then we can see the pink and the green are already set. So everything's going to be a log 6. So we'll rewrite this as log base 6 of 4, and then plus, because it's in the numerator, log base 6 of x plus 1 to the 1/4. And then because these next two are in the denominator, we'll go minus log base 6 of 5 minus log base 6 of y to the 2/3 power. All right, a couple of things you want to do. Remember, we're not done until we bring these exponents in front. So that's going to be our next step. And then go ahead and look at these logs and see if there's any evaluating you can do without a calculator. In this case, there's not, because there's not like a change of base rule, a common base rule that we can use. So we're just going to rewrite it as log base 6 of 4 plus 1/4 log base 6 of x plus 1 minus log base 6 of 5 minus 3/2, because this is supposed to be a 3/2, not a 2/3, as we can see from up here, log base 6 of y. And so that's expanding it out, and it's been properly expanded. If I check my answer key, hopefully it says the same thing, and it looks pretty good to me. So I'm going to go ahead and move on. So if you want to give this one a shot, then we can kind of see how you're doing. So, ladies and gentlemen, boys and girls, with this one, I'm going to move the 2 in front of this and the 2 in front of that. When I do this, I'm going to move this over a little bit so we have a little bit more room. I'm going to bring back the yellow pen. That looks fun. So log base 6 of x plus 1 squared plus log base 6 of x minus 1 squared. And then on the bottom one here, we'll change our color here to the orange, minus log base 6 of 36 minus log base 6 of x minus log base 6 of y. Alrighty, so everything is pretty well started with our expansion. The 2 obviously are going to go in front here. And then in the previous example, I mentioned, hey, can you change or reduce anything with our numbers? And that one is, you can. So if I rewrite this as log base 6 of 6 squared, because that's what 36 is, we'll have a common base rule. So that will cancel, and then that's just going to give me 2. So now that's a negative 2. Alrighty. So we're going to go ahead and have 2 log base 6 x plus 1 plus 2 log base 6 of x minus 1, and then minus log base 6 of x minus log base 6 of y, and then minus 2. It doesn't really matter where you put the minus 2. The answer key has it at the end, so I figured I would put it at the end. And this way you could see all your logs at the one time anyways, so we'll call that good for your answer. Alrighty. So ladies and gentlemen, boys and girls, we have our solving equations. I want to take a look at this, and I always look at these bases first. Technically that's to the 1 power, so that's why it's a base. And I'm like, could I do anything to make those the same? Like 6 to the 1 is 6, 6 squared is 36, 6 cubed, 216. So there's nothing that I could do to make a common base. So I'm just going to have to convert this. Okay, so when I convert this, this is my base. So it's going to be log base 6 of 125 is equal to x plus 1, because base stays base. So this is the base, it stays the base, and the other 2 pieces switch place. That was the one I always like to use. So now, basically, we're going to say, alrighty, I can solve this because it's log base 6 of 125, and then minus 1 is equal to x. So you can put this in a calculator. If you don't have a TI-84 that's been updated, you might have to put it in your calculator as 125 divided by log of 6 and then minus 1. But in either case, ladies and gentlemen, your answer, I'm just going to go the answer key for this one, is going to be 23 1.6, and then we have a 947. There we go. That's our answer for 23. 23B, this one is going to be a little bit trickier. So if I look at this would be a lot easier if they had the same base. So let me talk about the same base really quickly. So if you have 3 to the x is equal to 3 to the y, because they have the same bases here, you can go ahead and just say that x is equal to y. So in this case, I can't, because one's a 3 and one's a 5. But I can use my properties to find out what that is. So if I say, alrighty, 3 to the what power is going to give me 5? Because that's basically what I want to do. You always want to change the bigger number. So log base 3 of 5 is equal to y. So I don't have that number ready, so we're going to have to go ahead and find that. So again, you go to math and you go up to log base, and if you don't have to do that, you have to do the common log rule. So this is going to be 1.46, and then we might as well say 5, because it looks like it's going to be right here. 49 is going to round up to 5 pretty easily. Okay, so what that means is that 3 to this power is going to give me 5. So I'm going to rewrite this as 3 to the x plus 3 is equal to 3 to the 1.465, and then I had an x minus 1. So now, just like we did up here when they were both 3s, here they're both 3s. And so I can go ahead and say that this is going to be x plus 3 is equal to 1.465, and then x minus 1. So I would get all of my x's together. So ladies and gentlemen, distribute. We're going to get x plus 3 is equal to 1.495x minus 1.465. And then bring this x over, bring that over. We're going to get 4.465 is equal to 0.495x. And then we'll go straight to our answer here. Thank goodness we get a calculator. And so this is going to be 9.60264. So if it's me, I would stop at 3 decimal places. So I would say that x is going to be approximately, I'll use my little approximate, 9.603 after rounding. So, didn't mean to flip it there. Welcome back. Alrighty, moving on to 24. So this part here, it's 2 times e. So we're going to have to use the ln. But that's the e to an exponent. So that 2 can be divided by. And so we're going to do that first. So I have e to the 1 minus 2x is equal to 250. Now, since this is e and this is a 250, we're not going to make them a common or use the common base solving technique like we did on 23. So I'm just going to take the log of e of 250 is equal to 1 minus 2x. And log base e is the same thing as the natural log. So ln of 250 is equal to 1 minus 2x. So then I would say, okay, minus 1. So we have ln of 250 minus 1 is equal to a negative 2x. So we would divide both sides by a negative 2. So we're going to have x is equal to the natural log of 250 minus 1 divided by a negative 2, which is, let me see, this is 24. So according to my answer key, we're going to get negative 2.2607. All righty. So 25. All righty, so we have an ln here. So the first thing I'm going to do is I'm going to go ahead and say, all righty, remember that this really, that square root is to say that ln, and I'm going to rewrite this as 2x plus 1 to the 1/2 power. Well, if it's to the 1/2 power, just like we did with the expanding, we can put that in front. So 1/2 ln of 2x plus 1 is equal to 1. So then I can multiply both sides by 2, and I'm going to get ln of 2x plus 1 is equal to 2. Then we'll say, okay, ln is the same thing as log base e. So we'll say e to the 2 is equal to 2x plus 1 when we convert it. And so now we're going to solve that. So e to the 2 minus 1 is equal to 2x. And then when we divide both sides by 2, we're going to get our number. So I just plugged it in the calculator here. I got 3.1945. Yep, there we go. There's our answer. So that's it. The reason why we needed those expanding and condensing rules is to solve this, because it made it so much easier rather than getting this radical there. All right, moving on to 26. Now here is a little bit different because we have 2 logs on both sides. So the rule eventually I want to use is if you have log base b of x is equal to log base b of y, then we can go ahead and say that x equals y because these are just the same base. Well, I would like to do that here, except on this left-hand side, I have 2 logs. Can't have that. So what we're going to do is we're going to make this 2 logs into 1. We're going to go ahead and condense, hence why we needed the condensing part. So that's a minus, so it's going to be divided, so it's going to be log 2x plus 1 divided by 2 is equal to now log 3x minus 2. So again, whenever it's subtraction, it becomes dividing. So now they're the same. They're both log base 10. So we can say 2x plus 1 over 2 is equal to 3x minus 2. So the first thing I'm going to do is get rid of my fraction by multiplying everything here by 2. So that's going to be gone, and I'm going to get 2x plus 1 is equal to 6x minus 4. Bring the 2x over, I'm going to get 4x. Bring this over, I'm going to get 5. So x is going to be 4/5. Make sure I got that one right. Sorry, 4/5. 5/4. Been doing that a lot lately. I don't know why. Just making my fractions all goofy. Alrighty. So moving on to 26b here. So this 2 is going to make it so I can't do that same rule that I did on the previous example. What I'm going to have to do is make this side still 1 log by condensing and then convert it to exponent form. So it's a minus, so that's dividing. So it's going to be log base 3 of x squared minus 10 divided by x is equal to 2. So let's convert that. So the base is 3. So base stays base. The other 2 switch place. So the 2 comes over and that parentheses goes to the other side. So x squared minus 10 over x. So that's going to give me 9 because it's 3 squared is equal to x squared minus 10 over x. Then we're going to multiply both sides by x to get rid of that denominator x. So 9x is equal to x squared minus 10. And then I'm going to move over that 9x. And we're going to get x squared minus 9x minus 10. So we need to factor this because it's an x squared. So the 2 numbers that multiply to a negative 10 and add to a negative 9 would be negative 10 and a positive 1. So x minus 10 is equal to, oh, skipping steps, I apologize. X plus 1 equals 0. So we're going to get x minus 10 is equal to 0. So x equals 10 and x plus 1 is equal to 0. So x equals negative 1. All right. So ladies and gentlemen, boys and girls, on 26, if we look at our answer key, it says that there's only one correct answer, and that correct answer is 10. So why is that? Because we got 2 numbers. Well, whenever you get an x squared, be prepared, well, really any time, but really with an x squared, but it can happen in any situation. If you get a negative answer for your x, you got to plug it back in to check if it works. And the problem especially is that one. Because just as we said at the beginning, when you graph and your log looks like this, there's no way to get over into the negative quadrant. So how would a negative 1 work? It wouldn't. Excuse me. So that's why our answer is just 10 and not both answers. All righty. So, ladies and gentlemen, it says a population model in 1970 was 90 million. So this right here, I'm going to erase this so we can focus in on this example clearly. This is going to be my initial. And this 270 is great, but it's really just used to find how much time has passed between here and here. So in this case, after 35 years, because that's the difference between 1970 and 2005. And so this is what it is now. So it says find the exponential growth function. So the big thing that we are missing is the rate. Because, ladies and gents, we are looking for the rate, we're going to use our PERT equation. So A is equal to P to the R t. We're not going to use the other number one just because that when it was r over n, that's for money specifically. Alrighty, so at 2016, we have 216, and we'll just realize that that's million. I don't feel like writing those out. And then it's going to be e to the rate that I'm missing, and the time was 35 years. So because this e to the r is my actual exponent here, I can divide both sides by 90. So we're going to have 116 over 90 is equal to e to the 35r. So ladies and gentlemen, boys and girls, we are going to go ahead and convert this. So this decimal, let's do that really, actually, let's leave that. So it's going to be log base e of 116 over 90 is going to be equal to 35r. So log base e is the same thing as a natural log. So we'll have the ln of 116 over 90 and then 35r. So when we divide both sides by 35, that looks like we would put that straight into the calculator. So let's do that. So ln 116 divided by 90, that's not. Then divided by 35. So I get 0.007 and then 285, sorry, 725. Alrighty. So ladies and gentlemen, boys and girls, we'll go ahead and rewrite our equation because that's what it's asking us to do. So 90 was my initial, e to the 0.007, because again, that's my rate, 25 times whatever time passes is going to give us where we're at based on those two pieces of information. And that's our answer. Alrighty. And ladies and gentlemen, that is going to be it for, I don't know why that everything shifted on down here. That's kind of funky. There we go. So that's going to be it for our chapter 3. Hopefully this was helpful, and we'll see you next time. Take care.